This is a walkthrough for calculating percent yield. I'm going to do one example problem for you, and then you should be okay for the rest. There's only 3 on this assignment, so you'll have 2 to do on your own once you see me walk you through this one. I'm going to share my screen. I'm going to show you the assignment. This is what your assignment should look like. You should be able to click on that blue link right there. That'll take you to the formula, but we have to do a calculation before we're going to use this formula. So when we read through this problem, if we start with 12.5 grams of copper and we react it with excess chlorine, we're able to produce 25.4 grams of copper chloride. That's going to be what we call this right here is what we're going to call the actual yield. That's how much actually was produced. First, so then it says find the theoretical and percent yields. So we want to find a theoretical yield. We know that we actually produced 25.4 grams of copper 2 chloride, but we want to know how much copper 2 chloride can we produce with the 12.5 grams of copper that we started with. So we need to do a stoichiometric calculation, grams of copper to grams of copper 2 chloride. So we should hopefully feel pretty comfortable with stoichiometry at this point. We're going to do 12.5 grams of copper. Notice how we have a balanced chemical equation. Kind of skipped over that part. We have 12.5 grams of copper. We're going to convert that to grams of copper 2 chloride. The mass of copper is 63.55 grams for every 1 mole. So then we're going to take this from moles of copper to moles of copper 2 chloride. There's 1 mole of copper in the balanced chemical equation right here. And then there's 1 mole of copper 2 chloride in the balanced chemical equation. All right, so 1 mole of copper 2 chloride has a mass of 77.45. Oh, that can't be right. $134.45. That's just the molar mass. And we want to see what our theoretical yield is going to come out to be with those numbers. So I'm going to take 12.5 and multiply that by 134.45. Divide that by 63.55. And we figure out that our theoretical yield is 26.4 grams. Kind of running out of room there. But our theoretical yield was 26.4. Now, when we are calculating percent yield is actual yield divided by theoretical yield multiplied by 100. And that's how we're going to get our percent yield. Now, remember that we labeled our actual yield at the beginning of the problem. That's 25.4. So I'm going to write 25.4 on the top. Then we need to put that over the theoretical, which we calculated over here to be 26.4. So we're going to divide 25.4 by 26.4. Now this is a percent, so we want to multiply that by 100. So 25.4 divided by 26.4 divided by 100 comes out to be, or multiplied by 100, sorry, 96.2%. So our percent yield was 96.2%. That means we were able to produce 96.2% of the theoretical, which would be 100% of the yield. So we had a pretty good lab set up there. If we were doing this in the lab, 96.2% of our product was produced. Not much was lost there. Very good. So first what we had to do was we had to go from grams of copper to grams of copper 2 chloride to figure out what our theoretical yield was. Once we figure out our theoretical yield, this value right here, we then plugged it into actual divided by theoretical times 100, and we were able to find that our percent yield was 96.2%. Shouldn't have any problems with the rest of these. Same exact type of problem that you'll be asked. This is all in the grand scheme of what we're trying to do throughout this entire unit. This is just one of those steps. So we're doing great so far. Let me know if you have any other questions. Send me an email. See you next time.